Hello and welcome to DataCast Solutions, Statistics and Data Mining 101 using KNIME. In this chapter we're going to talk about residual analysis and how to interpret the information when the predictive model is not perfect. As we've said before, because a linear regression model is not always appropriate to the data, we want to use a scatter plot diagram to examine the residuals and look and see how they vary to the predictive line. So let's start by defining what is a residual. It's the difference between the observed value and the predicted value. Remember that the regression line itself minimizes the residual values between all of the various predictors, which ultimately means that the sum of all the residuals is going to be 0, and the mean of the residuals is going to be 0. The most important point is to look at the scatter plot diagram of the residuals in a graph form and look at them across the horizontal axis. If the points of the residuals are randomly dispersed, some are above, some are below the axis, a linear regression model is appropriate. But if you see most of them below, or if they're clustered together and they don't appear to be randomly dispersed, then we're going to look for a nonlinear model, and we'll be talking about that in future chapters. All right, so let's take a look at how we can look at the scatter plot diagram within KNIME. First off, if I actually just look at the existing scatter plot view, I can see that the data does appear to be the residuals appear to be fairly random and distributed, but let's actually look at it and see. So in the node repository, we can see our linear regression learner down here. I'm going to add a linear regression predictor, however, and drag that up to the model. Now, the connector, the actual model, the formula for prediction, is the output of the regression learner. And I'll put the data here and tell it that I want to create, it's going to create a default column called prediction. So in this case, movie revenue. And I can execute this. And then I'm going to add a math formula to this node. And I'm going to say that the predicted revenue minus the actual revenue is equal to a new column I'm going to add called residual. And I'll execute that node, and then finally I'm going to add a scatter plot diagram to this. And we're going to take the predicted revenue against the residual, and we're going to map that in a scatter plot. And I'll execute and open the view. And again, if I look at the 0 line right here, the difference between the ups and downs, the residuals appear to be fairly random along the residual line. There's not any clustering or anything that would indicate this isn't a good fit for linear predictive modeling. Some examples of what you might see are plot patterns. So what we saw was a random residual plot, some above, some below, no constant distance. Non-random residual plots will tend to be curvilinear, and you'll tend to see them in either U-shape or upside down U-shape. And that suggests that a curvilinear approach is a better solution. So as a quick summary, residuals are the difference between the observed values of the dependent variable and the predicted value of the dependent variable. And a residual plot, if the points in a residual plot are randomly dispersed around that horizontal 0 axis, a linear regression model is appropriate. Otherwise, a nonlinear model is more appropriate. That completes this chapter of the class. Feel free to move on to the next chapter.